Hello friends, today I am going to solve LeetCode problem on the day of 15 June. The problem is stated we have given a linked list of size n, where n is an even integer and the ith node of linked list is known as the twin of the n minus 1 minus ith node, where I value range from 0 to n divided by 2 minus 1. We need to find the twin sum that as the sum of our node and its twin, and we have given the head pointer of the linked list with even length, and we need to return the maximum twin sum. So what the problem stated, let's understand we have given a linked list, and the twin of 5 is 1, okay, and the twin of 4 is 2. To the summation of twin node and the 5 is 6, and for this is also 6, and we need to return the maximum value. So here for both the twin sum is value 6, so we return the value 6. Okay, let's take another example, this one. So in this case, the twin of 4 is 3 and the twin of 2 is 2. Okay, so here for this the summation becomes 7, and for this the summation becomes 4, and we need to return the maximum summation, so we will return the 7 value. Okay, let's check the output. Yeah, here is the output 7. So how we can do it? We have two options. For the link, for the given linked list, we create an array. Okay, we create an array of the same size n and map these linked list value in the array. Okay, after mapping this value into the array, what I need to do, we what I need to do, I will create a pointer that pointing initially pointing to the 0 1 0 index, and the last pointer that point to n minus 1. Okay, and we will traverse the array while left value is less than right value. Okay, and we will take the summation of array of left one and array of right one. Okay, this is the right one, and we will initialize a variable maximum sum, and at each iteration we will find the summation of array of L and array of right one, and after finding the summation we will update our maximum sum if the value is greater than our maximum sum. Okay, at the last we are returning the maximum sum. So what is the time complexity? The time complexity for this one, we will first traverse the whole linked list to map to create an array that takes O of n, and then again we traverse the whole array to find the maximum sum, but this time the iteration of the loop is n by 2. So total time complexity is this one. And what is the space complexity? Is O of n to create a new array. Okay, so this is the one way how we solve it. And what is the another way? So let me delete all this one. So we can, the first approach can be done very simply. So let's check what we want to remove the space complexity, and we want the constant space complexity, that is O of 1. Okay, so how we can do it? One approach that we create a new linked list, but this also take space complexity of n. So how we can do it? As we have given that the first node twin is the last one, and then the the first the second starting node on the first is the second last node. So how we can do it? Let's think. We have given this linked list, and we will, let's me create 5 4. From this node we will first find the mid node of the this linked list. Okay, so how we can find the mid? So we will take the code at the later. So first thing, that how we can find the mid node. So for this this linked list, this is the mid node. Okay, after finding the mid node, let's say here is the slow pointer, and here is the slow pointer, and okay. So you're thinking that why it is mid pointer? The mid pointer can be like somewhere between this, but in the case of linked list, we can assume that the next one is in the event linked list case. We can assume that the next one is our mid node. Okay, so we are thinking that this node is our mid node. Okay, after finding the mid node, what we can do? We will reverse the linked list from the this node. Okay, after reversing the node, what we will find? A new head pointer pointing to this, and our initially pointer pointing to this. Let's say temp variable 1, and let's say it is a temp 2, and we will traverse the linked list until the temp 2 variable becomes null pointer. Okay, so we will first here and here. So we will take the summation of both. For this case the sys, and we will update our integer value by sys. Okay, after doing so, we will move this pointer, we will move this pointer here. Okay, and this pointer here. After doing so, we will find the summation value of this one and this one. The value becomes again 6, so no need to update the mass sum. After finding the mass sum variable, what we will do? We will again reverse this in list. Okay, so we will again created our initial linked list, which is this one, and at the last we are returning the mass sum. So by doing what is the time complexity? We are finding the mid of the linked list that takes n by 2, and then we are reversing the half linked list that also takes n by 2. Then we are traversing again the half of the linked list to find the mass sum that again take n by 2, and then again we are reversing our linked list, half of the linked list that also take n by 2. So total time complexity become 2 of n. Okay, and here the space complexity is O of 1. So let's go into the code panel and let's check what is the solution. So this is the main function, and here we initialize our mass sum integer value by int min, and by using the find mid function we are finding the middle node of the given linked list. Okay, after finding the mid node we are reversing the half of our linked list. After doing so we are created two node pointer. One is pointing to the this head pointer, and the another one is pointing to this newly reversed linked list. Okay, as you can see. And while our temp2 variable is pointing to the null pointer, we finding the sum of both nodes, and we are updating our mass sum value, and at the last we are moving our pointer by next pointer. Okay, after finding the mass sum, what we are doing, we are doing again the reverse so that our linked list is consistent. At the last we are returning the mass sum. So this is the find mid function code, how we can find the mid pointer. So I think that you already know, but if you don't know, so let's check. We we have given this. So I take two pointer slow and fast. I will move the slow by one pointer and fast by two pointer. So now fast comes here. Okay, and we again move our fast slow pointer. So our slow pointer comes here, and fast pointer goes to the null pointer. Okay, and when our fast pointer becomes null, our fast next pointer becomes null. So we return the slow pointer. So this becomes our mid pointer. Okay, so this is how we are finding the mid, and for this is the code for reverse the linked list. So how we reverse the linked list? So let's say we need to reverse this linked list. Okay, after reversing this linked list, what we need to do? Let's say our previous node pointer at the initial pointing to the null. Okay, and our temp variable pointing to this one. Okay, so what I will do? I will take three variable. This point to previous one, and this point to temp one, and after we will cover while our temp is not equal to null pointer. Okay, so what we'll do, we will first create a node pointer to to assign the next pointer of this node. After assigning the next pointer of this node, what we will do, we will assign this next pointer pointing to the previous one. Okay, after doing so, we will move, let's say we move our next pointer to the previous node. Okay, this one, and we will update our previous pointer by this temp variable, and our temp goes to the next one. Okay, at the last, this becomes our head, and we will return our head. Okay, so this is the case. Let me run this code. It is accepted and it is also submitted. Okay, you can also use the array that takes space complexity of over n. That is also fine, but for the optimal case, you need to use this approach. Okay, and I have updated the lead code solution of today problem. This one here. mm, this application, you can find the lead code solution by going into the community section. Okay, so yeah, you can check it out. I already updated this one, and thank you for watching. Please like and subscribe. Yeah, the site loaded successfully, and here is the solution for the today problem. Okay, yeah, thank you guys.